Good morning, ladies and gentlemen. Thank you for joining today's iTrain session on to learn how to make machine learning work, our free webinar, which will be hosted by Faris, our trainer from iTrain. Before Faris's presentation, I would like to quickly introduce you to iTrain and who is the organizing body of today's webinar. So at iTrain, we are supporting digital transformation, and we are the pioneers and leaders in tech learning in Asia. And at iTrain, we believe in two core principles: the power of technology to shape the future and help us build a better world, and that love of learning is the source of human ingenuity and well-being. Our goal, which is backed by government and academia, is to fast-track Asian businesses with the latest technology applications and know-how. So these are some of the courses that we are currently rolling out. So we have courses in mobile development, blockchain, data science, Internet of Things, artificial intelligence, fintech, digital marketing, and cybersecurity. And most of the courses are also HRDF supported, and we are currently rolling out online courses as well. And we will be keeping our in-class courses once we're allowed to have face-to-face interactions with the students. But for now, we have master classes, and also next week we will have a master class in digital marketing. So all of this information about the master classes and online training you can find on our website, www.itrain.com.mi, as you can also see in the comments and the chat section. And yeah, so we have worked with companies all across many strategic sectors. As you can see, the companies that we have helped to digitally transform are in the sectors of finance, technology, industry, and manufacturing. So this is from my side. And yes, a quick reminder again, you'll be able to gain the access to the webinar's presentation and the recording once you fill out the feedback form that you can find in the chat and comment section. And if you have any questions to the presenter, Faris, you can write them in the chat box and the comment section of the webinar. So Faris, the floor is yours.
Okay, welcome everyone. So as you know from the title, today we are going to talk about how to make machine learning work. So I hope everyone is well with all the MCO that's going on. I'm glad to be with you today. So I tried to make sure that there is enough examples with the concepts that I will be demonstrating for you today. Nonetheless, if there are any questions, as Elizabeth mentioned, put it and I will try to go through them towards the end or whenever they are passed to me. Okay, so my name is Faris Hassan. I'm majored in AI. I work as a data scientist in FAVE, and I'm a co-founder in a small micro-saving startup called Pod. So the objective of today's webinar is mostly around the concept of functioning ML. So how can we build a functioning machine learning for our business to solve any of the problems that we might be facing today? There are two main objectives for today's webinar. So we want to learn about 4 aspects of a functioning machine learning project. What are the aspects of building a functioning machine learning, and how can we in the same time understand the underlying process for a correct learning problem diagnosis. As you know, data today is what makes the world go around, and it is the premium asset for businesses and organizations. There is hardly any possible way to build an intelligent system relevant to the 21st century that's not powered by data. And as one of the authors for a book called Hands on ML, Orlean Jern expresses it, that there are two problems mostly that happens in any machine learning project. And this problem is either you have a bad data or you have a bad algorithm. Most of our built scientific methods in machine learning and deep learning today depends or operate by consuming data and provide relevant insights or intelligent insights to us. So the algorithms cannot operate in their own on a raw data. Therefore, the need for a deeper understanding of the data and the domain of the problem to build a meaningful feature. So today's webinar, we will shed a light around the most typical issues faced in working with machine learning pertaining to data and algorithms. We will look into the four aspects of this functionality. I will look into a problem statement or the prescription of a machine learning solution. We will look into a few of the data issues and evaluation metrics and how can we evaluate our machine learning model. And we will look also into optimizations and the importance of optimizations in our projects. Before we get into this, I would like to highlight the domain of machine learning businesses that we have today. And there are three ways we can characterize or categorize analytics today. We can look at them as a descriptive analytics, predictive analytics, and prescriptive analytics. A descriptive analytics is basically explaining what happens, and this is where most of the businesses are familiar with today, looking into tracking certain KPIs and have reports on daily, weekly, or monthly basis. But then there are the other two types, which is a predictive analytics, where we are trying to predict something about the future. We might try to predict if we have a problem, or we are trying to predict if, for example, the sales or prices in stock market and so on. This is the predictive analytics is the main generator for of insights for data-driven organizations. The prescriptive analytics is another type where we are trying to get a recommendation from the machine to achieve a desired state or a desired result, which why we call it a prescriptive. It's in a way an algorithmic prescription to achieve a desired outcome. And these two types, prediction and prescription or prescriptive analytics, is what the machine learning is about today. Machine learning does not really describe things for you. We are already familiar with our statistical methods on that. Machine learning comes to aid us on propelling predictive models and prescriptive analytics. Now that we got that out of the way, let's look into, for example, the prescription, or the first type of, or the first aspect of a fundament of a functional machine learning. The first and most fundamental aspect of building a functional machine learning is proper problem statement and prescription. So describing the problem is awfully important. A data scientist or machine learning engineer is then expected to draw down the potential causes and derive a prescription to the problem. And so let's look into it from this perspective. Let's take an example of a problem statement. So usually in the business, where what data scientists or machine learning expected to do is that to help solve the problems, but the problems are not always coming from the data scientists or the machine learning engineers. Most of the time, the problems could be faced by different people on different departments. So in a way, they are the ones who will define this problem and putting a problem statement. In this example, we have, for example, a problem in a certain company with customer service, for example. I think so many delivery companies face this during MCO. So let's say there is this hypothetical situation where there is a drop in customer satisfaction for a certain service provider. More customers complaining the long time it takes to handle their inquiries, and often it results in a bad experience. So a problem like this does not look like it have any machine learning or data science on it or anything, but that is, you can say, good enough to be an example for us. If we are reading this problem statement, we will focus on two things. There is a low number of customer care personnel, and there is a growing number of customers. That's why the inquiries are coming, but they are not churned out or processed in the same speed. This is a perfect example of a problem that is faced by many organizations today. The data scientist will have to take it from here, from this raw business form, go and take it forward to the next step. First, there has to be a well-defined problem, and that contributes a lot to the concept of the solution. If we even look into the basic, problem, we will see that there is a time problem. It takes a lot of time for them to process things. And there is a volume problem where there are more customer service inquiries that are coming in. So there is a well-defined problem, and that contributes to this, to how we will view the solution. Now, imagine how many possible ways there are to express this problem. And using the command of your English language, you will have so many ways that you can express this problem. And there is a dozen of them that are ways to explain the same problem, but in a more confusing form. And the reason why this might be a bit cloudy is that the person or the data scientist who is working with it will keep thinking about prescribing a solution. And the solution that needs to be proposed has to solve the root or the causes of this problem. Being is that there is a low number of people, so how can you increase the efficiency of the customer care department so they can do more with the same number? Assuming that an organization is moving into digital transformation, and they don't want just to keep hiring an army of customer representatives. Or maybe because also, as you know, like not all the inquiries might be of a higher urgency. So how can we know that? So let's think what the data scientist might think about when he received this problem statement. In my opinion, the data scientist will focus on two things. First, he will think about how to reduce the number of inquiries. Of course, will not be by stopping people from sending inquiries, but there has to be a way to reduce them. One solution I would think of is maybe how we assign a priority. So when a query comes, there is an automated way to assign each query with a value that constitutes how urgent it is. It is high urgency or low urgency. This way gives the customer care department to deal with the important inquiries first. Maybe we want to look into classifying the types of inquiries, for example. We want to look at, for example, when an inquiry is coming, it has to be categorized as payment, delivery, missing item, or etc., etc. So maybe we have few categories of inquiries, and we want to do this automatically in a way that, for example, our customer care representatives will have to look into, for example, payments issues faced first and delivery items or delivery issues first. So these are just hypothetical solutions. The second solution that a data scientist might think about based on this problem definition is that how can we provide an automated response to primitive inquiries? Some of the inquiries could be thinking about, for example, oh, how do I track my delivery, for example? There is, as you know, today, if you are asking for a delivery, they usually send you an email with the delivery tracking ID and so on. But maybe some people are new to this or they're not familiar with it. So they will keep asking questions that are, primitive inquiries that you can solve in different way. So the second solution a data scientist might think about is, how can we provide an automated response to such primitive inquiries without engaging our human resource in it? And if I ask, why do you think this data scientist will be focusing on these 2 points, reducing the number of inquiries, or categorize them or prioritize them, and providing an automatic response to primitive inquiries? Well, we can say that the problem statement has scoped down the problem to be arising to limited time and resources. So he will try to compensate for this limitation with automation via machine learning. And in this way, the whole thought will be like, okay, is this definition problem that you are providing, is it a machine learning use case? The second type is, or the important aspect that comes connected with it, is understanding the types of learning we have in machine learning. So in machine learning, we have 3 types of learning. We have a supervised learning, unsupervised learning, and reinforced learning. The 2 types of learning are the most relevant or the most applicable to our business today. That's where we generate most of our value in the whole world. Reinforced learning is used in other things like algorithmic trading and self-driving cars. And if you are in that business, then that type of learning might work well for you. So the importance of understanding these types of learning is that it makes it easier for you to, whenever someone gives you a problem, you kind of already see it on a certain shade. So, for example, in supervised learning, you have a targeted data of the prediction collected over time or annotated. So let's say you want to predict what users are gonna churn, what user is gonna drop out of your platform. So understanding what type of users will drop out of the platform Okay, I've been told the connection is this all right? Is it clear?
Well, it's just from now it's smooth, but like maybe in 5 minutes it will like lag again. So if you can disconnect maybe your phone from the same Wi-Fi, then like just, yeah.
Okay.
Some small things that maybe could improve, but all in all, it's good. Thank you.
Okay, all right. Okay, so back to the example on supervised learning. So in your platform, you might have operated for a few months or a couple of years, and you have accumulated that data about users. And then when you come to think about predicting if a new user or what kind of users are going to churn, it would be easier for you because you have already collected the data. Now it's your basically your course of action to annotate this data, mark down or label those who have churned, and from there on, you have a complete basically runway towards building a supervised machine learning model. And that's somewhat the case. So whenever we have a historical data that's in place, and we can use it to help build a training data set. supervised learning is a use case that mostly works on that. There are some other types of problems where we can't really know. For example, in unsupervised learning, it comes to solve on the other side of things. For example, you want to look at how many inherently distinguishable types of users you have in your platform, maybe based on activity, for example. You can go on and try to do this using statistical methods, but statistical methods is, to some extent, you are trying to meet halfway, and you are trying to look into or to define which users fall in any of your buckets of user segmentation. But in using a machine learning, unsupervised learning, what you will gain from it is that it has automatic segmentation. So the algorithm will learn from the data without even any historical previous records of these users, and it will try to give you a new structure of how this behavior of these users in your platform looks like, which is more of adding a new knowledge to us, helping us to explore structure or explore behaviors of data in our platform. And I hope that it sounds for you that these two things are somewhat quite different, and they look into different problems in their use cases. Reinforced learning is basically, it's expected to learn from the environment and model a proper behavior using what is called as a reward function. This is a small, just a tree to basically connect each type with what kind of tasks that we can have. So if you look here into supervised learning, we will be having two types, classification and regression. In classification, among the type, you'll have customer retention, image classifications, and so on. The examples that we had about the customer care representative or department that has too many inquiries. And so the solution that we thought that a data scientist will look at is how they can prioritize these inquiries automatically, algorithmically, before any human deal with them. That would fall under the use cases under this circle, which is more of classifying which priority band an inquiry belongs to. But there are others as well. If you're looking into, for example, market forecasting or trying to predict sales or predict prices of a certain commodity, you would look into the other wing of the circle, which is more into regression. However, there are still different types here. You can look into, in the unsupervised learning, you can look into, for example, targeted marketing, which is I think it's what you will do based on your, for example, user segmentation. And you will look also into recommender systems, which they basically algorithmically generate lists of movies that they know you will like based on your previous history, what kind of movies and series you have looked at in the past. And then they try to, based on that, they try to suggest or find what kind of movies you should watch like next. And welcome to binge watching from there on. YouTube as well works on the same way. They try to keep you in the platform for longer, and you see the business model in that. If you have stayed in Netflix and you find a ton of movies that you like, you'll keep your subscription. When you keep your subscription, they are making money. So yeah, so that's like how the nature of it is going and how the business application of it. So a safety tip when you are dealing with this is look into basically similar use cases. So usually a data scientist, after a few years of working on this domain, they will gain this, you can say, this sixth sense, where they will understand, or they will be able to identify or to recommend a solution, prescribe a solution just based on a problem description. They can guess of that right away. But not all the businesses are facing a typical problem. Some business might be facing, a niche problem depending on the market or depending on their own, circumstantial characteristics. And for this kind of case, one thing you would look at is you would try to look into, for example, reading for McKinsey Analytics or any of the big consultation firms where they share mostly new applications. And that will help you even know if there is no famous solution of your problem, there might be someone in the world who have tried to solve it in a certain way. And from there on, you at least have a hint of what a solution could be for this problem. So the second aspect of a functional machine learning is the data issues, how adequate the representation of the data. As you said, people think usually that as long as you have data and you have a lot of it, then that is good. But actually, it's not always the case. There are other problems with data regardless of the volume. There are 5 most important data issues that almost everyone in the field will face today. For example, you will look into a problem of insufficient data, sampling bias, bad quality or irrelevancy of features, and the problem of under and overfitting. These data problems, I call them data problems, but they are directly impacting the performance of the machine learning algorithm. So relevancy of features might dictate how well an algorithm will perform. Underfitting and overfitting is a problem comes from the data, but inherited to the algorithm where it will not be able to generate proper prediction. So I still refer to them, and in most of the community, data science community, look at them as data issues because they come from the data, but they are faced, or you see them and you see their impact on your model performance. So in terms of sufficiency of data, so certain machine learning use cases are sufficient with few hundreds of examples, but insufficient data cause increase in variance, which contributes to the performance issues like overfitting. So I will give you an example of this startup in the United States, in New York. They are building a prediction for settlements. So they want to build a model where they want to look at your case before you go to the court. They want to look at your case and predict for you how much compensation you will get if you went ahead to court. But if you look at it, it is quite a tough problem. Why? Because there are 3 things that will reduce the data you have significantly. First, outside influence. So now let's say you have looked into all the kind of settlement cases in a court in the country. What you will find is that quite a number of these settlements have outside influence. So the case has been settled under pressure or under blackmailing, or the company decided to cut losses and they just decide to, accept whatever settlement is there. So the settlement value was not actually objective. It was actually influenced by an outside influence that you will not know at all. And that really reduced the numbers of the number of cases that you might have. If you have 1,000 cases of this type, maybe 50% will go out or will be removed because they are under outside influence. The second thing is, how many of these settlements have been part of a deal? So the compensation value there, instead of becoming 2 million ringgit, it became maybe 700K, because this case was part of another major or minor case. So the settlement was, or the compensation was somewhat calculated in a different way. when people deal outside the court, they can do it in any way they want. And what happens is that somewhat basically adds some misrepresentation to whatever settlement compensation you have. Another thing is computation. So you might get the similar cases on a similar scenario, but on a first scenario, the compensation has been, for example, few millions. On the other one might be 1 million. And for you, having no knowledge of what went behind, you might not know what made this case getting more compensation than the other one. Such factor could be like the way they have calculated the compensation and so on. And these factors or this computation methods that resulted in the difference in the compensation value might be very hard for you to actually add and bring to the data. So what happens is that if you are trying to look and put a rigorous work into all the cases, at the end, due to these factors and others, you will be left with a very small number of cases that you can say they came natural. They were, the result out of the court. And that's what I mean by insufficient data. The data that you're left with at the end is too small and might not be, a representative of all the cases or of all contexts that are there. The second problem is non-representative or inaccurate representation. So the machine learning model can only perform and generalize well when it's trained on a data that reflects the natural representation. So for example, among one of the cases you can look at is skewness. So let's look into this balance problem. For example, if we have a data that is separated by gender, you might see something almost close to 50% between the two genders. But if we are looking into, for example, the banking sector, and we are trying to build a solution for detecting what kind of transactions that could be fraud, we will see that 99% of transactions, of daily transactions, are actually genuine transactions. There is only 1% fraudulent transaction. And what happens is that this 1% of fraudulent transaction is the result of one or two types. It does not cover all the possible ways a fraud could take place. And what happened with it is that you will have no sufficient meaningful representation of the fraudulent cases that are happening. And that skewness could be, it will add this, basically, it will add, it could be skewness to the left or to the right, to either of the cases. But what it will result with is that your model will be very the highest population. Another problem that comes from non-representation is the survey empty data. As you see in a survey, you will have some questions that are optional. And as a result, if you are dealing with this kind of data and you want to build a machine learning model of it, is that when certain responses are not recorded or ignored, or they were optional, so most of the people ignored it, then this makes the representation incomplete. That section will be out of there. And what happens is that the other data that you have, the other responses of the questions, might not be giving you the full idea, just because there were some responses that might as a distinction that have been left out. And that's basically what is meant from non-representative or the inaccurate representation of the data. In machine learning, we always what we do is we are trying to generalize. We are not trying to be 100% perfect about applying something. So if you look even in here on this small graph, we have 3 types. So in the underfitting, what is happening is that there is a naive straight line that's supposed to, let's say, separate our data from what is class A. For example, what is fraud, what is not fraud. We just put a straight line, and what's happening is that it's underfitting. It does not actually generalize well and makes a meaningful separation between our two types of transaction, if you want to put this about the transaction example. And if we are trying to do as in the third one here, in the third graph, and we are trying to exactly predict where each piece of data, where each transaction belongs to, it will result for us on what's called overfitting. Overfitting is basically the machine learning model understood very well the distribution and the probability of the prediction on the training set. So whenever we have a new data that is coming, it will have different distribution, and therefore the model will not be able to work perfectly on them. What we are trying to achieve is the appropriate fitting. We are trying to achieve a way that is not 100%, but good enough. It could be an 80 or 90% accurate, and that depends on the domain and the context of the problem. Poor quality is the third aspect of functioning machine learning. And when we look into quality in data, there are 4 aspects of quality that we're looking at. First is the missing values, unrecorded empty observations in the data. It could be a result of, for example, just completely missing data, for example. Let's say it could be like, for example, the users you have in your platform did not provide their, for example, their birth date, and as a result, you don't have their ages, and that's kind of a missing value. But there are other types of missing values. For example, if you're looking into IoT or any kind of data that's generated by machines, missing values will be a result maybe of faulty sensors. So it will be a result of faulty sensors, or a result of the processing within the collection phase of the data. Some of them by mistake has been dropped or missed out. The second type of problem that makes data poor is outliers. Outliers is mostly values that are, you can say, they do not really fit into the distribution. For example, you have if you have, for example, a sales or an e-commerce, and there is just like one user who spent 60,000 in one day, of course you can know that, okay, this person is not, we don't know what's wrong. It's good that he is buying in your platform, but for your data, in the context of your data, this is an example of outlier. All the people on 12.12, they spend maybe between 100 to 700, and this person just spent 60,000. And you have to deal with such people distribution of your users. Another type is errors. For example, you have presence of invalid digits or non-text in the text data. It somewhat happens quite a lot of the times, and it can be dealt with in the pre-processing phase, where most of the time for the data scientist is spent on that phase. There is another type, which is the noise, the irrelevant data combined into a data set. For example, you might have a data predicting anything, and you might get columns that, for example, have ID numbers, and each ID number is basically, it's not unique to your data, it's more unique to your hardware, for example. And if you're not like in the manufacturing or in the maintenance, that could be just an added feature that is not really significant. It does not add so much value to your model. That example will be clear when we look into the third aspect of a functioning machine learning, which is irrelevant features. So in machine learning, what we do is that we will have a lot of raw data, and the machine learning engineer or data scientist will work with this data, transform it, and engineer new features out of it. These features can happen either a result of extraction or generation. In the extraction, the feature extraction, we are basically creating new features, like using computer vision technique to extract image descriptors. For example, we are trying to build a camera that identifies the person by his face ID, for example, his face. So there are algorithms for computer vision that will extract how your face looks, and this, the graphical descriptors of the face or the picture. And these features are based on mathematical concepts and vision concepts. And they are well-known algorithms across the board on almost everything. So that's an example of how we extract features from certain data. But there's another type, which is generation. So in a generation, we will use existing features combined with new ones to generate new set of features. For example, we will look into so in generation, it really can happen in so many ways. So basically, generation, it could be based on the birth date of your users. You will generate a new feature called age. So did the user provide you with the age? Not really. They provide you only with the birth date, but you were able to generate the age feature. This is a simple example of how you generate features. You use an existing data to generate something new. And basically, if you have generated too much data and you have generated so many, you will end up with a number of them might be insignificant, not really important. They are irrelevant features. That means the machine learning model could not learn anything meaningful from them. And you have to deal with that. It's not really a problem, but it is an aspect of how you build a functional machine learning. You see, in the workflow of a machine learning, there is a phase where you will think about features engineering. And you will have to brainstorm what features can you get. And you will write maybe 20 features. Does that mean all of them will be important? All of them will be relevant? No, but that means this is all the ideas that you can try out. And only then when you go on to the testing phase, where you will be learning what are relevant features, what are not. And there are multiple methods, among them feature importance, where you try to rank each column or each feature in terms of how does it contribute to correct prediction. And that's how you can work with this aspect and resolve it. So in the whole machine learning process, features engineering is the most important. As Professor Andrew says, coming time-consuming, it requires expert knowledge. For example, finance, then it will require knowledge into finance. But the gist of it is that applied machine learning is basically features engineering. It's not about what algorithm have you used. The algorithm does not contribute in the same magnitude as your features. Your features is the king. You might have a simple model, something as a decision tree, but due to the meaningfulness of your features, it is able to outperform even something as complex as neural network. There is and there comes one of the famous issues that you will have to look at in the machine learning, which is the bias-variance trade-off. So you remember when we talked early on the first aspect of functional machine learning, we mentioned that insufficient data would be a problem. It will increase. It will introduce basically a problem with the variance. But if you don't have a proper representation of all the classes, you will introduce bias. So if you look into here, let's say like, so if you have a high bias, that means your model is predicting one type very well, but it does not actually, spread to the other types because it did not learn from them. An example of that, how we would be predicting, for example, which transactions are normal transactions, which ones are fraudulent transactions, due to the fact that fraudulent transactions are very small in population. Most of the time, your model will suffer from a problem like this. Of course, there are solutions, but here I'm mentioning the problems that you need to be aware of. On the other side, the flip coin of it is when we have high variance, your model just spreads prediction across the types or the classes you have. It does not have like adequate bias. As a result, it basically underperform. It does not perform well in all the classes. It will perform maybe 40% or 60% in most of them, which is quite bad, because if your model is basically performing at 50% accuracy, then you should be worried, because 50% is almost like random guessing. You can just guess randomly and you might outperform your own machine learning model. So there is a trade-off between them. We are trying to achieve a point between bias and variance where it is good enough for our case. And it is easier said than done. You have to perform multiple tests and to know that if you are suffering from any side of this bias variance issue. The fourth metric, or the fourth aspect of building a machine learning model is, so now we got all the problems out of the way. Problem of prescribing and defining the problem is the first one. The second one is a problem with the data that you have. And the third, or basically, yeah, mostly with the data. And the third one is like, okay, now you have dealt with all these issues. The fourth part is how to measure your success. Your model is good. There's no problem with the data, no problem with the distributions and so on. And your model is expected to work well. Now, how do you know that it works well? Well, that comes with the evaluation metrics or performance analysis of the performance. There are two types of metrics you will look at. There are the statistical metrics and there is the business KPIs. So I wouldn't say like you have to focus on one and leave the other, but you have to look into both of them in a moderate manner. One thing is that so in statistics, we will look into the model accuracy, we will look into precision, sensitivity, if we are dealing with classification, but we will look into MAE, or mean absolute error, which is have to deal with regression issues. Anyway, this is the statistics, how statistical metrics. For you, because the whole point of this exercise of building this machine learning is to solve the business problem. So how you will know that it solved the business problem? Statistics is not enough for you to just judge the performance. You need to look into business KPIs, something like the ROI, the CR, or the click rate or click-through rate, and the other intangibles. For example, for example, like maybe you have introduced something from a machine learning and it does not convert user instantly, but it results in conversion later on. For example, it increases the knowledge about your offering in your audience. So when you look into it from this perspective, you will be able to have a proper idea of how well this model performs. And you will always have that insight that, are we solving this problem properly? For example, one of the cases that you can look at is, for example, in e-commerce, for example. You will see all the e-commerce, Lazada, eBay, or whatever is out there. They will always have recommendation of products for you. Now, this recommendation of products, if you, let's assume that you are the person behind this, you will look at two things. You will look at how much ROI is coming from this segment, but that's only one metric. So maybe a low ROI is not desired. You need higher ROI, but you can look into click-through rate. For example, maybe the users clicked into one of the items in that segment, in the carousel, but they did not buy the item they clicked in. They clicked there, they went into other items, and they converted there. So they did not convert on the interface directly. They converted after a few clicks. And when you look at that from this perspective, you see that, okay, our model is actually still good. It led some of the users into conversion or into a click-through rate. So the click rate is also important. Why? Because of the intangible it provides. If you are having a platform with 20,000 products, for example, or you are like YouTube, they have millions and millions of videos, then if you do not have a way to recommend for each user a personalized list, what will happen is that only few of the videos in YouTube will be having high views. The rest of them will not, because there is no discoverability. So if you are having a recommendation system, for example, there, what will happen is there will be discoverability for new products and for new videos, and that will keep your users basically engaged, and they will follow up and most probably stay longer in your platform. Yep. So the fourth aspect of I think I confused metrics for the fourth. It's the third. Fourth is the optimization. So what are we talking about when, or what do I mean when I mention optimization? Well, optimization is, you can say, the real life stuff. So there is hardly any machine learning problem that you can pick up off the shelf and implement it in your offering directly without modification. And these modifications are not in like on the data level or anything. It could be more towards your business or more towards your type of users. So it could result on a better user experience or improving performance in general. So, for example, let's take a hypothetical situation of e-wallets today in Malaysia before MCO. Now MCO just stopped everything. So e-wallets before, like Grab, Boost, Touch and Go, even FavePay, and so on, they depend in their basically they depend on users going to the shop and pay. Now, if they or optimized towards location. Why? Because the conversion of the business does not happen online. It's not like Lazada. You buy, it's from China, it comes to your house. In the case of e-wallet, no. These people, they need to walk down, or in most of the cases, I mean, like when you pay, I'm not talking about the delivery services, I'm talking more of the others, like the restaurants or cafes. You are expected to walk down to the cafe and transact there, scan the QR and make a transaction. So if they are recommending for you something, it has to be optimized for location. Why? Because that will increase the performance, improve the ROI, and so on. If you are recommending people to go for cafes in Bangsar while they are in KL or in downtown KL, they will not, maybe they will not even use it after some time. Why? Because you are giving them some form of irrelevant insights. You are advising them with things that are far away from them. But if you are optimized well enough for example, 10 or 5 or 3 kilometers around them, then you have higher chances of conversion. The other thing, so it improve ROI or click-through rate, and to improve that people, they know what are you offering. Also, it comes like with dynamic pricing as well. As you know, like if you are booking, especially for flights today, when you book from Malaysia, it's not the same price as like if you booked from Singapore. It's not the same price if you book while you are in Australia. So that dynamic pricing is a form of optimization. And the hypothetical example of optimizing for location for e-wallets in Malaysia, it's a hypothetical example how that will improve the performance and how that will result also in a better user experience. Users will always see few of the restaurants or cafes in the homepage that are within a walking distance from them. And that mostly is where your magic happens. The algorithms will be the same, everything will be the same, but you cannot take a use case off the shelf and think it will work perfectly. It will work a little bit well, but for you to achieve success, you have to double down on optimization for what is unique about your offering, what is unique about your service. So, and therefore there are 4 challenges I have identified. No, I'm running a bit out of time. There are 4 challenges that you'll have to manage, and one of them is that managing expectations. Unrealistic expectations in your organizations might, give you a very, a few number of shots to try machine learning, and also it might give you a hard time with explaining the performance. Your first version of the model might not give you the best ROI, but you need to have the moderate expectations and the support to try to optimize, improve, and put on the second version, the third version, and see your numbers going up and improving. So managing those expectations are very important. If you are a machine learning or a data scientist, on this point especially, try not to oversell. Try to be a bit adding a salt of reality, because it might hurt you back again. Project management is another challenge. Even though, like, machine learning and data science is not that, it's not that similar to software engineering, but in the same time, it's not that different from it. So you will need to find a project management way that blends or benefits from software engineering life cycle, and in the same time adapts to the uniqueness of the data science workflow or the machine learning workflow. The third will be tracking and monitoring. You remember when the 4th aspect of machine learning, of functional machine, we mentioned about metrics. So those metrics and KPI needs to be tracked well and monitored. You need to define them very well, because this is like the defined way to know if this whole project is worth it or not. And it is easier said than done. You will need to implement, maybe like even try to go 1 mile ahead just to have this meaningful and accurate tracking and monitoring for your model. And the third or the 4th challenge is maturity. So driving your machine learning to maturity will take you some time. It might take a month and so on, but it is one of the challenges, as you need to still keep on expectations and support from there. So the best tips is to look into an MVP, and basically a small scope of the project first, and build on from there onwards. The second thing will be like look into A/B testing, maybe trying 2 models on the same time for a small percentage of the users. And maybe you will need to also leverage on tech and that will be basically using CI/CD, containerization, and so on. Okay, so at the end, as they say, imagination is more important than knowledge. So you need to keep that up and look out there for solutions. Today we exist where the online space is rich, and you find a lot of guidance, and you'll find people who worked on certain problems. I just want to share with you these additional readings. So there's this executive guide to AI from McKinsey, which is something I really liked. It's well crafted and advice for you to check in if you are even if you are in the field. Just check it in, and I'm sure you will love it. You will see the use cases, the business use cases to different algorithms and different machine learning types. This second article is just 10 red flags about your analytics program, what to understand and what to know about, what might lead to failure in your program. And the third one, just notes from the AI frontier, the value of machine learning and deep learning to organizations that might, ring a bell of a similar use case on your platform. So at the end, I'm looking forward to your questions for now. Elizabeth?
Yes, thank you for your presentation, Faris. At the moment, we have not received any questions, so we can give a few more minutes for people to come up with any questions if they have any. But in the meantime, a reminder to those who are still with us to fill out the feedback form to receive the presentation, and from there you can access also the links that Faris has shared. So once you fill out the presentation, fill out the feedback, you will gain access to the presentation, and in the presentation you get the clickable links to the additional readings. But yes, looks like no questions are coming in. So thank you very much, Faris, for your time and for the presentation. And if anybody has any additional questions to Faris, you can email them to info@itrain.com.mi as well. Or yes, you can see also Faris's personal email, so you can get in touch with him directly. And if you have any questions about the courses and what iTrain is currently organizing and hosting, you can check that out also on iTrain's website, or follow us on Facebook for the latest updates. But yes, so yeah, no questions. So it was very self-explanatory then, Faris. Thank you so much.
Thank you.
And yeah, so yeah, thank you all for joining.